So today we are learning principle of reversibility of light. This principle states that if a light ray after suffering reflection and refraction get its direction reverse, its direction reversed, then the path, then the ray of light can retrace its path. Okay, so if a light ray after suffering reflection and refraction gets its direction reversed, then the ray of light can retrace its path backward. Let us understand this with its theoretical applications, with some derivations. So for example, imagine that this is a vessel which contains a liquid of refractive index N2, absolute refractive index N2. This is the normal, this is the incident ray, this is the refracted ray. The ray is incident on a plane mirror, So if this ray falls on the mirror at an angle of 90 degree, it will again, its angular reflection will also be 90 degree. So it will retrace its path backward, or not. So you can see this is what is happening. The ray of light after getting reflected, after first getting refraction, then getting reflected on the mirror by 180 degree, then it retraces path backward from where it has begin. So when this happens, for first refraction, so refraction is taking place in two times. So the first refraction, when the ray is going from O A B, when the refraction taking place O A B. So for first refraction, what can I write? According to Snell's law, I can write, okay, let's say this is N2, this is N1. So I can write sine I, this is I, and this is R, sine I by sine R equal to N2 by N1, which we can write, it is going from 1 to 2, so correct. For the second refraction, that means when the ray is traveling back along BAO, I can write, because now the incident angle is R, so sine of R by sine of I equal to, so you are going from 2 to 1, so N1 by N2, which is 2 to 1. So this is my equation 1, this is equation 2. So if I multiply this 1 and 2, equation 1 into equation 2, if I do, what do I get? I will get sin I by sin r into sin r by sin I equal to, so first time it was going from 1 to 2, so n 1 2 into, next time it is going from the refractive, from the medium 2 to medium 1, so it should be 2 to 1. So you can see here I and I get cancelled, R and R get cancelled. So we can write, right hand side can be written as now 1 n2 into 2 n1 is equals to 1, or we can write 1 n2 is equals to 1 by 2 n1. This is the relation which is obtained when the ray of light will retrace its path backward, then the relative refractive index, one can be, if one is not here, some other medium, then the relative refractive index of the two medium will be reciprocal to each other. Okay, let us see a practical application on this one. I will show you one demonstration in the physics engine. Here you see I have set up the same environment. I have used a vessel filled with a liquid of refractive index, of certain refractive index, and this is a mirror. Okay, and there is a laser which I have kept it as the source of light. Now what is happening, you see, now what I am going to do is, now I am trying to rotate this, see what happens when I rotate. So if I try to rotate it, you say it's going away, but then if I gradually bring it back, it is path ray has got reversed. Now you see it will come to a particular angle, there the ray has again retraced its path backward. Got it? This is principle of reversibility of light. So and when these happen, we can say that when this is going to happen, if this is the normal, this is the normal here, when these happen, then let's say the refractive index of this one is n2, this is air n1. So when this is happening, we can clearly restate that n1 to 2 is reciprocal to, is equal to 1 by 2 n1. This is the relation what it is established when the ray of light retraces path backward like this. Understand? Hope you have enjoyed this small demonstration as well as the theory on reversibility of light. If you have enjoyed it, don't forget to like it, share it and subscribe my channel. Thank you.